Hey everyone, welcome back to my channel. I'm Hossein and today we are starting an exciting new video, a mini Spotify-like backend from scratch using NestJS. In this video, you'll learn how to create a complete music streaming platform with features like user authentication and registration, music file upload and streaming, playlist creation and management, like and favorite system, and also you're using RESTful API design. This project is perfect whether you're learning backend development, preparing for interviews, or just want to build something cool. Everything runs locally so you can test it with Postman as we go. By end of this video, you'll have a fully functional music backend that you can extend with your own features. So grab your favorite drink and let's dive right in. Alright, before we start coding, let's get the project set up on your machine. I've prepared everything as a template so you can follow along easily. First, you need to make sure that you have Git, Docker Desktop, and your favorite code editor installed. Then, the step one would be to clone repository. So let's go ahead and clone repository. Let's say git clone. So the next thing we're gonna do is to create our env file. As you can see here, we have .env.sample, which I'm gonna make a copy out of and just create an env file, paste these things right away. The default values should work perfectly for local development, but feel free to change the passwords if you want. Now the next thing we're gonna do is to start Docker engine. I'm not going through installing Docker. You can go ahead and install it on your own, but you have to have it installed on your machine. Now, as you can see here, Docker engine is running, so this step should be done as well. And as soon as the Docker engine is running, it's time to do step 4, which is launching the project. I'm gonna say docker compose up -- build, and as you can see here, this command is gonna start everything: database, Redis, pgadmin, and even our whole backend. Now it's time to verify everything works. Once everything is running, we should have main app at localhost port 3000. Where is it? Yep, right away here. So let's open up a PowerShell. I'm gonna say curl http:/localhost 3000, and as you can see here, we have the status code 200 and it says okay. We even have another route, which is basically this one /health, or let's say health check it was. Yeah, as you can see here, we have status okay with timestamp of now. If you see these responses, you're all set up and ready to code with me. Now, let's see what's coming next. In the next few minutes, we'll start building our first endpoints. We'll create user authentication, set up our database models, and get our first API routes working. If you are following along, make sure to like this video and subscribe for the rest of the video. Drop a comment if you run into any issues during setup. I read every single one and I'm here to help. Alright, let's start coding. Now that our basic project is running, let's start building our authentication system. This is the foundation that will secure our entire music platform. First, we need to install a bunch of packages for authentication, database, and validation. So let's go ahead and say npm install at NestJS JWT, NestJS Passport, NestJS type ORM, Passport JWT, Passport local, bcrypt.js, class validator, class transformer, type ORM, pg, NestJS /config. After that, we need to install a bunch of TypeScript definitions for these packages. So I'm going to say save dev at types/bcrypt.js at types/passport Passport JWT types / passport local. What are these packages used for? JWT is for token-based authentication. Passport is for authentication strategies. Type ORM will handle database operations, as is the ORM of Postgres. Bcrypt.js is for password hashing, for the security of passwords. And finally, we're using class validator for input validation, like the parameters that is being sent to our API. Now, before we go any further, let's just go ahead inside .env and use 5432 instead of 5433. Okay, it's a more common one. Now it's time to configure our database connection in app.module.ts. I'm setting up type ORM with PostgreSQL. So first of all, we need to import two things. Import star as .env from .env. So we're gonna load our environment variables inside our app.module. So I'm going to say .env.config. And after that, I'm going to import type ORM module. Thanks AI autocomplete. Type ORM module from the package we just installed. Now inside imports, I'm going to import type ORM module. And I'm going to say for root. This one is going to take a bunch of parameters. So the type of the database is going to be Postgres. We're having host as process.env.db host. Next thing is port. We're going to use a number process db port. Username is going to be process.env.db username. Next thing is going to be password process.env.db password. Next thing is going to be database. This one, database process.env.db database. Yep. Auto load entities is going to be true for now. And finally, in development mode, synchronize is going to be true. Notice that this line .env.config call is crucial for loading environment variables from your env file. So make sure you have this before importing anything using environment variables. Now the next thing I'm going to do inside main.ts file, we're going to use a validation pipe. So I'm going to say app that use global pipes. And I'm going to create a new validation pipe. Now this validation pipe is going to take a bunch of parameters. First one is going to be whitelist, which is going to be true. This will actually remove unknown properties from incoming request parameters. Transform is going to be true. So this one transforms types automatically. And finally, we're going to use 4-bit non-whitelisted to true. This one basically throws an error on unknown properties. After that, we're going to use this set global prefix, and I'm going to go with API/v1. This is a global prefix for all our endpoints. Now our foundation is set. So we need to create our user entity now and start building the authentication flow. But before that, let's test out the whole app. So I'm going to say Docker compose up -- build. All right, so it says no configuration file provided. Oops, we're in the wrong directory. So cd to EchoNest. Then Docker compose up -- build. Let's see if it works correctly. If our application is running, everything should be good to go.
One eternity later.
As soon as you see these logs, starting Nest application, mapped API/v1, it means that everything is working correctly. But before going any further, let's go ahead and see what pgadmin is, and actually let's create a server, register a server inside of it, and see our database. So in order to do that, you need to go to localhost 5051, as we have this address inside our environment variables, this is the port. So the pgadmin4 is going to be running on port 5051 locally. So let's go ahead and use our email address or username and our password. What is it? admin@admin.com. You can name it whatever you want. And the password would be 123. As you can see here, pgadmin is loaded. It's a great user interface to interact with our database. But before interacting with our database, we need to actually register a server. So the name would be main. You can name it whatever you want. In the connection tab, you need to use the host name and address. DB host is going to be DB. The port is going to be 5432. Username is going to be, let's see what it is. Username is going to be Postgres. Password is 123. So password is going to be 123. So now inside of main, you can see our databases, and you can see this EchoNest exists. We can see everything related to our database, which we'll be using it throughout the whole course. Let's create our user entity. This will be foundation for our authentication system. So first of all, let's create the user directory structure. So inside src, I'm going to create a users directory. Now in users directory, I'm going to create a file called user.entity.ts. Inside here, we're going to export a class called user. This user class is going to have a bunch of parameters. These parameters are actually going to be saved on our database, and we're going to use type ORM and PostgreSQL to do that. So first of all, ID, which is going to be a string, and its type is going to be primary generated column. We need to import that from type ORM, and inside here we're going to pass UUID. Then we're going to have a column. This column is going to be unique. It's email. A username, so I'm just going to make a copy out of it. Username, which is going to be string. Password, this also is going to be a string, but between column and password, we're going to use something called exclude. Now this exclude thing is going to exclude passwords from JSON responses that we are sending back to our client, which is pretty crucial. We never want to show our passwords to client. So we have a column. Nullable is going to be true. It's going to be first name, which is a string. I'm going to make a copy out of it. This one, next one is going to be last name. Next thing is going to be something which by default is going to be true, and that thing is active, which is Boolean. After that, we're going to have some timestamps. So create date column, which is going to be created at, type is going to be date, and yep, we need update date column, which is updated at. Great. Let's import this one as well. And these are the properties we need for user at the moment. But before going any further to write our business logic and module, we need to do a bunch of other things as well in this file. So before updating and creating our passwords, we need to hash them, right? So let's go ahead and say before insert and before update, we're going to do something called hash password. You can name this function whatever you want. If password exists is actually not null, we're going to use something called salt bcrypt.gensalt, and I'm going to pass, let's say, 12 to it. We need to import bcrypt. So import store as bcrypt from bcrypt.js. Then we're going to set password to be equal to a hashed password. Using hash function of bcrypt, we can go ahead and do that. We then need a function to validate password. So let's say async validate password. This function is going to take a password, which is a string, and then it's going to return bcrypt.compare password, incoming password, with the password which is saved on database. Okay, so this return value should be a boolean. This compare method of bcrypt is gonna always return a boolean. So type of the return is gonna be promise of boolean, because we're working with an async function. And the last thing is something for practice, and it's totally optional. It's gonna be a getter function, full name, and it's gonna return this dot first name, or actually none, and this dot last name, or none dot trim. So let's review what we have here. There are a bunch of key features of our user entity. First thing is UUID. This is a UUID primary key. This is more secure than auto incrementing IDs like 1, 2, 3. This is gonna be another thing. The security level is much higher than auto incrementing IDs. We have unique email and unique username. We have password hashing, password exclusion. We never return password in API responses. Timestamps, which are very useful in APIs. And finally, we have full name, which is the combination of first name and last name. We can debug this later if there's a problem, but for now, we can go ahead and create our users service. So users.service.ts. If you are not familiar with TypeScript and basically NestJS structure, in NestJS, for every module, we have a module file, we have a service file, which is actually our business logic, and we have a controller file, which we are using to expose our API endpoints. So in here, I'm going to export a class called users service. This user service is going to have a constructor, and inside constructor, we're going to use something called inject repository. In this repository, we are passing user to. What is this user? This is the entity we are working with. So we're going to inject our user repository to this user service so we can use it here. So let's go ahead and import that. And after that, we're going to need to create an instance of it. So we're going to say private read only user repository. And the type of our user repository is going to be repository, which is coming from type ORM. And we're going to pass in the user to it. Let's import inject repository from NestJS type ORM as well. Now, what do we need to write inside our user service? We need to implement everything that is database related stuff. For example, find all users, find the user by ID, find the user by email. So let's go ahead and implement find methods, create methods, update methods, and delete methods. These are going to be actually so similar to each other. For example, to find all users, I'm going to say async find all. The type is going to be, type of return is going to be promise, an array of users. Now inside here, I'm going to say return this user repository find, and in here, I'm going to pass a bunch of stuff to it. Only active users, select ID, email, username, created that, and updated that. So instead of doing redundant work in video and waste your time, I'm just going to copy paste all find methods as I have them right away. Great. So we have find by ID, find by email, and find by username. You have access to this whole files in our GitHub repo. Make sure to check it out and start it if you want. Next thing I'm going to implement is our create method. Actually, not methods, it's just one method. So async create. We're going to create a new user. It's going to return that user. This is where I'm using something called partial in TypeScript. It means that not every property in user is crucial. Some of them are optional, and just some of these are enough to be included inside this user thing. We need to check if email, then we need to check if username exists, and finally we need to create user. How can we check that? We need to use find one method, or we can use find by email, right? As we have it implemented. Existing email, for example, this find by email user.email. Then we're going to say if existing email, we need to throw new conflict exception error email already exists. We need to do the same thing for username, right? Existing username. Here we're going to say username already exists. And in here, we're going to use find by username. So if none of these two cases above are true, we can go ahead and create the user. So let's say const user repository dot create user. But there is a conflict between these two names. So let's go ahead and use new user for it. Then I'm going to return this dot user repository that save new user and instantly return it. So the next method is going to be update. Update is going to take an ID, a new user data, partial of user, a promise of user, and inside here we need to do a bunch of things. We need to find the user. We need to use object that assign user this new user data. We need to save and return it. So this .user repository that save user. But between find and update, we need to check if the user is not gonna update their email, their username, and their password. Password updates are some things that we need to handle separately. So I'm gonna say delete new user.email, delete new user data.username, and password. We need to handle this separately. Now for deleting a user, we're not gonna actually delete a user. We're gonna use something called soft delete. It means we are just gonna deactivate the user. As you remember, we had something called isActive, which is a boolean, and every user should have it in their properties. When we are going to delete a user, we actually need to keep their data as we might need them later and have this isActive to false for that user. Deactivate, that's gonna take an ID, it's gonna return a promise of user again, and basically we have deactivate all lowercase. We're gonna first find the user, and then we're gonna say user is active to false and return this user repository that save user. At last, we have a validate user. This one is going to take an email and a password. It's going to return a user or null. So first, we're going to find the user, await this, find by email. Maybe we find the user, but he's deactivated. So instead of using find by email method directly, what we are going to do is that we're going to say this dot user repository dot find one and check if the user is activated, where email and is active true. By using this expression here, we are making sure that the user is active. Then we're going to say if user and await user dot validate password of password return that user. And if this expression is false, return null. Now that our user service is done, we can go ahead and create our user controller. This file is going to be used to create REST API endpoints. But before going further, I remember something. Before using this export class, we need to use something called injectable. We're going to use this to inject this user service to our user module later. We're not going to be able to use this user service if we don't use this injectable here. We need this injectable phrase in users controller as well. Then we're going to say export class users controller. Inside here, we again are going to use a constructor. We are going to be using this user service inside user controller. So I'm going to say private read only users service, which its type is going to be of type users service. By the way, we are injecting this user service to this class. So another reason why we need injectable here. The problem is that we are using injectable instead of controller. This is a controller and our server needs to map the APIs we are assigning to this class to the whole application. So we need to use controller keyword instead of injectable so our server knows about this. Now let's go ahead and implement our methods. First one is a post method. This is used to create a user. So I'm going to say create user. We have a body. The body name is going to be user data, which is of type partial user. The user is coming from user entity. It's going to return a promise of user again. Then we're going to say this dot users service dot create user data. In order to save some time, not actually waste your time, and make you learn something about this course, make you actually learn something, do something throughout the course, I challenge you to go ahead and complete this file. Go ahead and create some API endpoints for the activating user and find methods. Also, I need you to make sure that you include update in our controller. To learn something, to do something, pause the video, go ahead and do that. And when you play the video again, I have all methods pasted in right away.
A few moments later.
I hope you did it. I hope you wrote this file by yourself. Let's continue. Let's go ahead and create our module, users.module. In here, I'm going to use a module. Inside my modules, I'm going to use imports. First of all, type or a module for feature. I'm going to pass user entity to it. This line means that, hey, type ORM. I'm using user entity inside this module. Controllers in this module is just user controller. And the providers, we can pass users service. And just for now, copy this line. We're going to see why I am exporting users service and type ORM module in a minute. Finally, we need to export users module. One last thing is to register this users module inside our app module. Let's say users module, and we are good to go. Finally, let's test our app. Docker compose up. Let's see if everything is working. Nice. We have no errors. As you can see here, we have post, get, patch, and delete methods. These are controller methods, right? One post, two gets, one patch, and one delete. Great. So our app is running perfectly. Now, let's make our API more professional by adding proper validation and clean data transfer objects, aka DTOs. DTOs ensure we only accept valid data and return clean responses. I will provide a link in the description to get you more familiar with DTOs and how they work. Feel free to check that out. First of all, let's create auth directory. And inside auth, I'm going to create a new folder called DTO. And in there, we're going to create a bunch of DTOs. Register.dto.ts. Let's get rid of all these open files. Export class register DTO. First of all, we're going to use something called isEmail. This field is coming from class validator. We're going to say, please provide a valid email address. Then we're going to say is not empty. And inside message, we're going to say email is required. And the field itself is going to be email, which is going to be a string. Our next field is going to be username, which is a string. And we need to apply some rules to our username. First of all, we're using is a string. Message is going to be username must be a string. We need to use is not empty. Message is username is required. After that, we need to specify max and minimum length required for usernames. We're going to use min length. Let's go with 3. And the message is going to be username must be at least 3 characters long. And the next one is max length. It's going to be 20 characters. The message username must be less than 20 characters long. We need usernames to only contain letters, numbers, and underscores. So for this purpose, we're going to use something called regex. So I'm going to say matches a certain regex, and the message is going to be username can only contain letters, numbers, and underscores. And as you can see here, my AI suggests this regex, which is totally true. You can learn about more regex in the provided links in the description. Feel free to check them out if you want. Our next field is password. We're saying is a string. Message is going to be password must be a string. Password is not going to be empty as well. So we're using is not empty. We're saying password is required. We also need to apply min and max length. So let's go ahead and do that right away. But the length are going to be different. First of all, let's say this is password. So for min length, we are going with 8 characters. And for the max, we're going to go with 50. Finally, we have 2 optional properties. First name, she's going to be a string, and also last name. Let's say is a string. First name must be a string. Let's do that right away for last name. Both of these are going to be optional. So we're using is optional from class validator. And finally, we're applying some max length for these two. Max length is going to be 50, and the message is going to be first name must not exceed 50 characters. Great. And this is going to be last name. We are done with our register DTO. Let's go ahead and create another DTO for login. So we are using the same structure for email and password. So let's say export class login DTO. And we have email and password. We don't have min length and max length because they're only required inside register DTO. There we go. Our login DTO is done as well. Our next DTO is going to be auth response.dto.ts. We're going to use this one in the auth section. So first of all, let's create our user response DTO. We are using something called expose. These are coming from class validator, and expose is coming from class transformer. Let's see what expose does. It marks the given class or property as included. So basically, expose means that we are including that field inside our user response DTO, inside the sending response to our client, right? So what do we have in user response DTO? First of all, we have ID, which is a string. We need to expose email as well. Let's make a bunch of copies out of it. The next thing is going to be username. Then we have first name. We have last name. First name and last name could be provided by user, so these aren't necessary. We have is active, which is going to be a boolean. We have created that, which is a date. Finally, we have expose, updated that, which is date as well. Finally, we have one exclude option. This exclude marks the given class or property as excluded. It means that we are not using this property. We are not sending this property inside our response to our client, right? You guessed it, password. We are not sending password. We're excluding password from our response. Finally, we have the constructor. We have partial here, and inside constructor object that assign this partial. Basically, constructor is creating a new user response DTO, but we haven't created auth response DTO yet. So let's go ahead and export a class called Auth Response DTO. When a user logs in or registers a new account, we are first of all exposing a user. This is the user info. So user response DTO. We are also exposing an access token. Now let's create our constructor. We are taking a user, which is of type user response DTO, and an access token, which is a string. Don't worry about this access token yet. We will be implementing and explaining all about it in our auth section. So don't worry about it at all. User is gonna be user, and access token is gonna be this incoming access token. Finally, let's create our last DTO, which is update user.dto.ts. We have the same structure that we used for register, but we are just allowing user to update their first name and last name. Let's say export class update user DTO. Let's paste our stuff here. Now that we have our DTOs implemented, it's time to update our user controller with new created DTOs. First of all, inside create user, instead of user data, we are just going to use register DTO, which is coming from register DTO. And in here, let's use register DTO. And instead of returning this right away, we are going to use this user response DTO. So let's say I'm going to mark it as async. It's returning a user response DTO. And finally, let's say user response DTO, and we're passing a user. Now you understand why we implemented the constructor here. We are using this constructor to return a new user with this data, which is partial of user response DTO. Next, we have find all. We are doing the same thing, user response DTO, users await, and then return users that map. We're taking each user and create a new DTO for it. User response DTO, and we're passing in the user. Function is going to be async as well. For this one, user response DTO, const user await, return new user response DTO user. Let's mark this as async. For our update, we are using update user DTO. What is the type of update user DTO? It's this one right away. There we go. And it's returning a user response DTO. So user await, return new user response DTO of user async. Finally, our last controller is deactivate. It's returning a user response DTO, const user await, and we have return a new user response DTO, which is the user itself, and async. This section is done. We have done a great validation by using, as you know, DTOs. So by using DTOs, we have email validation. We have valid email format required. An email cannot be empty. We have username validation, 3 to 20 characters long, only letters, numbers, underscores, no space or special characters included. For password security, we have minimum 8 characters. And for clean responses, we have password never returned in API responses. We have consistent response format and proper error message. Perfect. Now our API has a professional validation and clean response structure. In the next part, we'll be creating the authentication module and actual login and register endpoints. Before we dive into building our authentication system, let's understand the core concepts that make modern web authentication secure and scalable. This foundation will help you understand not just how to implement authentication, but why we make certain design decisions. what is authentication versus authorization? Authentication answers a simple question. Who are you? Who is this user? So authentication verifies the identity of a user. As an example, we can refer to logging in with email, password, biometric verification, or social OAuth, like logging in using Google or GitHub account. On the other hand, authorization answers what can you do? Authorization determines what resources or actions a user can access. As an example, we can refer to admin privileges, premium features, or role-based permissions. Now, let's talk a little bit about JWT, which stands for JSON Web Token. This is a modern approach to implement authentication in a system. A JWT is a compact URL-safe token format that contains JSON data. Think of it as a digital passport that proves who you are. The structure is something like this: header, payload, and signature. This is an example of a JSON Web Token. We have header, we have payload, finally we have our signature. Payload is the data we are packing into JWT. For example, imagine we have this data, we are packing this data into our JWT as our payload. And signature is a part that does the verification for us. It uses some encryption methods and it combines payload with a secret key that we and only we know about. I will provide more information about JWT. Feel free to check them out. Now let's talk about how JWT authentication works in action. First, user login. So it means that the user sends their credentials to the server. Then server validates. For example, checks the email and password against database. If password related to that email or username is correct, then we can move on to next level. In the third level, server creates JWT, which means we sign the token with our secret key. We send back the JWT to our client, then client gonna store JWT, usually in local storage or memory. From now on, client sends JWT in authorization header as a bearer token, which we will do in a second. Now for each request that contains JWT token in authorization header, server verifies JWT and validates signature and extract user info from that payload we provided before in order to create the JWT. In order to implement JWT in our application, we are going to use something called Passport.js. Passport is a popular authentication middleware for Node.js that provides a strategy-based authentication. It's flexible and modular. By the way, it's framework agnostic, which means it can work with Express, NestJS, HyperExpress, or other frameworks. How Passport works is that we register a strategy. We basically define how to authenticate. For example, we want to use JWT, local strategy, OAuth, or any other strategy available in Passport. Then we are integrating our middleware. So Passport validates requests using strategies as a middleware in our application. Some of the common Passport strategies are local strategy, for example, which is based on username and password itself, JWT strategy, and finally, OAuth strategy, Google, GitHub, etc. Now we understand how Passport and JWT work together. So let's go ahead and start implementing our authentication module structure. Great. Now let's create our authentication module. This will handle user registration, login, and JWT token management. We will build a complete auth system that's ready for production. Let's create the necessary directories. So, guard directory. We have a strategy directory, decorator directory. Now inside auth, let's create auth.service.ts. I'm using injectable, export class auth service, private read-only users service, which is coming from users service. And another thing is JWT service, which is coming from JWT service. JWT service is coming from NestJS /JWT package. Now the first function we're going to implement here is register. Register takes a parameter called register DTO, which is of type register DTO, and it's gonna return an auth response DTO. Now let's use a try catch block. Let's first of all create user through a user service. So let's say const user await this dot user service dot create register DTO. After that, we're going to generate our JWT token. So how do we do that? It's very simple. First of all, we need to create our payload. Payload is going to have a sub, which is user.id. And I'm going to pass an email as well, which is user.email. We're going to create our access token. We're going to say this.jwt.service.sign payload. Great. Now we have our access token as well. And finally, we're going to return the response. So let's say user response is new user response DTO, and we're going to pass in the user. Finally, we're returning new auth response DTO, which is the combination of user response and access token. Now for the catch block, we're going to say if error instance of conflict exception, then go ahead and throw error. What does it mean? It means rethrow validation errors from users service. This will basically does this. And finally, if not, throw new conflict exception, and we're going to just say registration failed. Now the next function we're implementing is login. Login receives login DTO, which is of type login DTO, and it's going to return a promise of auth response DTO as well. So first of all, we are validating user credentials. So let's say const user await this dot users service dot validate user, and we're gonna pass in login DTO dot email and login DTO dot password. So if the validation fails, go ahead and throw new unauthorized exception, invalid email or password. So if the validation is successful, let's generate the JWT. We're gonna use exactly the steps that we did in register. So let's say const payload is as a sub, we are using user.id, and as an email, we are using user.email. Let's create our access token. This, the JWT service that sign with our payload. Let's return response const user response equals new user response DTO, which we're passing user to. We're returning new auth response DTO, which is the combination of what? User response and access token. Finally, let's create our last function here, validate user by ID. It's taking a user ID, which is a string, and it's returning a promise of user or null. So in a try catch block, let's return await this that user service that find by ID of user ID, and on catching errors, just return null. A strategy in NestJS is a class that defines how authentication should be performed. Think of it as a blueprint that tells Passport how to validate incoming requests. There are a bunch of key concepts in this regard. So we extend Passport strategy. All strategies inherit from this base class. Then we implement validate method. This is the core logic for verifying credentials or tokens. This class returns a user object. User object is what gets attached to request.user. And finally, throwing exceptions is how to handle authentication failures. Now that we understand what a strategy is in NestJS, let's implement our JWT strategy that handles token validation for protected routes. So in here, let's create a new file, jwt.strategy.ts. Injectable export class JWT strategy extends passport strategy, which is being exported from passport JWT. In constructor, we have private read-only auth service. We are exporting auth service. Now, this class has a bunch of properties that we are custom defining them using this super keyword. So JWT from request. So extract JWT from auth header as bearer token. This means that type of token is going to be bearer token. We're going to set ignore expression to false. And finally, we have a secret or key. Instead of process.env.jwt secret, I'm just using a simple string called a super secret key. Now let's implement our validate function, which gets a payload. The payload is of type JWT payload. We're going to define this in a second. And let's say user this.auth service that validate user by ID. And then we're going to pass in the payload.sub to it, which is, let's say, sub is equal to user ID. Finally, if no user is found, throw new unauthorized exception. Let's say user not found. And if the user exists, then simply return user. Finally, we have this interface of JWT payload, which has a sub, which is a string, and email, which is a string. We are done with our jwt.strategy.ts file, and our strategy is implemented successfully. Now, the next concept that we're going to talk about are guards. Guards in NestJS are classes that determine whether a request should be handled by a route handler or not. They implement the can activate interface and return a boolean or promise boolean to allow or deny access. Now, think of guards as bouncers at a club. They check if you are allowed in. Or middleware with superpowers. They can access execution context and metadata. Or we can even think of them as route protectors, applied to controllers, methods, or globally. Now, there is an execution order in which the guards will be executed. First of all, we have global guards. They execute first, then controller guards. The third are route guards. And note that all guards must return true for requests to proceed. Also, note that the execution context provides access to the current request in guards. Now let's create a simple but powerful guard to protect our routes. So inside guard folder, let's say jwt.guard.ts. Let's use injectable again and export class JWT guard extends auth guard, which is coming from NestJS Passport, and then we're going to pass in the JWT itself. And this is our guard. Now our guard is implemented successfully as well. Finally, it's time to implement our parameter decorator. A parameter decorator in NestJS is a function that extracts and transforms data from the incoming request before it reaches your route handler. They provide a clean and declarative way to access request data. We have a bunch of built-in parameter decorators that have been working on so far. For example, using @body decorator, we have access to request body, @param gives us access to route parameters, and so on. Execution context is a powerful abstraction that provides access to the current execution context across different types of applications. For example, HTTP, WebSocket, microservices, and etc. By the way, we have access to execution context in the implementation of a decorator as well. Now it's time to create a convenient decorator to get the current authenticated user. So inside our decorator directory, let's create a file called current user.decorator.ts. Remember, this is a function. So let's say export const current user. We're going to use something called create param decorator here. And it's going to receive a function as a parameter. So inside this function, we have access to data, which is type unknown, and the ctx, which is coming from execution context. Inside this function, we are using context switch to HTTP and get request. This is giving us the request object, and we are simply going to return request.user. That's it. Now we have everything ready to implement our controller. So let's go ahead, create a new controller, auth.controller.ts, add controller. We are using auth, so it means that our API would be something like this: API v1/auth and slash blah blah blah. And in here, I am using something called use interceptors, and I am gonna go with class serializer interceptor. Now, this class serializer interceptor is a way to work automatically with class transformer library to exclude the fields that we wanted to be excluded inside our DTO, like for example password, and to expose the fields that we wanted to be exposed. Okay, so it's necessary to apply it here. Then I'm going to say export class auth controller inside constructor private read only auth service. Now we have a bunch of route handlers. The first one is a post, which is going to be register. So let's say register. In here, I'm going to say body, which is a parameter decorator in NestJS, register DTO, and it's going to return a promise of auth response DTO. So let's say return this.auth service.register. Let's pass in register DTO. Finally, we have another post method, which is login. So let's say async login at body. We have access to login DTO here. We are receiving it inside our body, and it's going to return a promise of auth response DTO as well. Then inside, we're going to say this.auth service.login with this login DTO. And finally, this is where we are using that guard and that decorator we've just implemented. So let's say add get profile. Let's also import get method, async get profile. So in here, I'm using this current user, which is of type user, and it's gonna return a promise of user response DTO. So let's say return new user response DTO, and then pass in the user. Finally, it's time to wire up everything using a module file. So auth module.ts. I'm going to use add module, and inside here I have imports. We are importing users module, passport module, JWT module. We need to register JWT module with a bunch of data. So first of all, secret is going to be a super secret key. We're going to set a expiration date. So let's say sign options expires in, let's say, for example, 7 days. Then we're having our controllers, auth controller. To our providers, we are providing auth service and JWT strategy. And finally, we're exporting auth service. Finally, let's export class auth module. One last thing is to register our auth module inside our app module. So let's go ahead and say auth module. There we go. Now that we have built our authentication system, let's test it together. We're going to use VS Code's HTTP book extension to create comprehensive test scenarios. So, as you can see here, I've provided a request.http file with different test case scenarios. You can send each request using these buttons, and then you can see the output and check if the system is working perfect. But before doing that, let's go ahead and run our application to see if there is no error and everything is wired up correctly.
One eternity later.
Good. As you can see here, our NestJS application has been running successfully. So we have API v1 auth login, profile, register. We have everything wired up correctly. There we go. Now it's time to test out our backend. So let's open up request.http. We're gonna start. I'm not gonna test all of these. It's such a complete test case scenario, but I'm not gonna test them all. I'm just gonna test some crucial functionalities. You can test them out and let me know the result. So first of all, we're gonna register a new user. Let's execute. It says registration field. Let's see if any log is provided here. Yep. Okay, so it says no metadata for user was found. Let's see. Let's check our entity file. Okay. All right, something I forgot about was that I haven't added an entity decorator to this class. It's a type ORM class, so we need to add this decorator before class. Now let's test our application again. Let's see if it works now. Perfect. As you can see here, we have our access token and user. Boom. It's working seamlessly. So let's use this access token to get our profile as well. This is register. Let's search for profile. As you can see here, we're getting profile. I'm gonna replace it with this token here. Let's send our request now. Oops, it's returning an empty object. Why is that? Let's check our controller. Auth the controller. Let's go to our profile. Okay, we are using current user, but we are not using our guard, and that's why the bird token that we are sending to backend is not being processed and the payload is not being extracted successfully. So let's say use guards, and I'm gonna use JWT guard. Beautiful. Now let's rerun our app and test if the problem is already gone. Before getting our profile, let's go ahead and log in with the credentials we just registered with. Let's go to login. So we have this, and we have strong pass. Let's log in. Nice. Password is gone in the response, and let's use access token. So inside profile, let's get bear, send the request. Nice. As you can see, we have ID, we have email, username, first name, last name, and created that. Great. Wow, look how far we have come in this episode. Let's take a moment to appreciate what we have built together. A production-ready authentication system that any company would be proud to use in their applications. What we have accomplished today was security best practices, from token storage to password hashing, even password exclusion from responses. We learned how strategies work under the hood, how guards, decorators, and interceptors working in harmony. We now have a complete authentication system with comprehensive validation and error handling, secure credential verification, and JWT generation. JWT-based route protection that just works fine and seamless, modular, testable, and maintainable code structure that we can use anywhere in any project we want. You guys now understand how modern web authentication works. Congratulations! You've seen the complete flow from user registration to protected API access, and you know why each piece is important. You now have a solid foundation that you can extend with features like refresh tokens, auth integrations, and role-based access control, and more. But wait, we're just getting started. In our next episode, we are diving into one of the most important features in modern web applications: file upload. File upload is one of those features that seems simple on the surface, but has incredible depth that you need to learn about. We'll explore everything from basic single file uploads to enterprise grade file processing systems that can handle lots of files. So make sure to subscribe and hit that notification bell because episode 2 is going to be absolutely packed with practical, real world file upload solutions that you can use in your projects immediately. Drop a comment below if you have any questions or feedback. That is so valuable to me, and I'm going to be reading and answering every single one of your comments. Your feedback helps me create the content you actually need. Thank you so much for coding along with me today. Seeing you build this authentication system step by step has been incredible. The fact that you stuck through all the concepts and implementations and the testing shows you're serious about becoming a better engineer. Keep coding, keep learning, and I'll see you in the next episode where we tackle file uploads like absolute pros. Until next time, happy coding.